Let's talk about some equations that we're going to solve.
Can you try to have a conversation with the online class? 5:30 to 5:45. Can you just yell on the whole? Have a game last night? Yeah.
All right, the first thing we're going to talk about is
Oh, do you have a game Saturday?
a concept, a logical kind of procedure that you want to think about every time you come across an equation. Okay? Say I get to the ACT or I get to, I don't know, some college entrance exam or something like that where it's time test and they're asking me to solve an equation. Okay? And maybe you don't remember how to solve it. Okay? Maybe that is an issue. If you have technology with you, okay, you can solve these pretty easily. You can find the solution pretty easily because when we solve an equation, okay, similar to this, let's say an equation involving a radical, when we solve it, we're simply saying that the left-hand side of the equation is simply its own graph. So we just graphed the left-hand side. The left-hand side was 2x. Okay? So we graph that. The right-hand side, if I can do this. I know it's kind of hard to see, but that's even harder to see. All right. The right-hand side is 1 minus the square root of 2 minus x. Okay, so that's something that you could type in to your TI 83 or 84. Okay, and you type the red one into y1, you type the blue one into y2. Okay, the solution to that equation, the x value that we're looking for, is the x value of where those two things intersect. So right now we're seeing that they intersect at negative 1/4, right? That's the solution to that equation. Is that all right? Okay. Every time you do an equation, that's the logic. That's what we're thinking about. Okay. Now a lot of times, our goal is to maybe when we solve equations, especially with a quadratic form, we try to get 0 on the right hand side, right? Okay. Well, the right-hand side then is a graph of y equals 0. So you'd be trying to see where your left-hand side crosses the line y equals 0. And the line y equals 0 is just the what? The x-axis. Okay. So that's kind of a quick shortcut that you can use if you have the technology at your disposal. I do know that some college exams don't let you use calculators. Okay. And I just want to see what you know in that regard. I want to give you that tool, allow you to use that, but I'm going to also, on test, need you to show work because I think the ability to solve these things is going to be very useful in other things that you do. So we want to develop that skill, and using the calculator just to get answers is going to inhibit from that skill developing, right? So we do want to still be able to do this stuff by hand. That's the logic behind this, okay? So if I start, and I'm going to kind of jockey back and forth between the computer and the whiteboard up here, so just kind of bear with me here. We have the equation. We started with 2x is equal to 1 minus radical 2 minus x, right? Okay. If we have that root equation, okay, we need to first, and this is no matter what your radical is. Okay, right now it's a square root, right? There's an understood 2 out there, that's called the index. Whatever that index is going to be the power that you need to raise that expression by. Does that make sense? So if it's square root, I need to undo that by squaring. If it's cube root, I need to undo that by cubing. Okay? They're inverse operations. But you can only do that, and it only makes sense to do that because if you did it now, you're going to get a much more complicated radical side. Okay? So it only makes sense to square and get rid of a radical once you've isolated it, once you've gotten it by itself. Okay? Because if I just start squaring this side right away, I'd have to FOIL that, right? And if you think about FOILing, first times first would just give me 1, so that'd be nice. Last times last would get this to be 2 minus x, which would be nice. But then O and I are going to give me that times this whole thing, and then you double it. So my middle term my O and I's added together are still going to have a radical in them, right? That kind of makes sense? So doing that first doesn't make the problem any easier. So the first thing you have to do is isolate the radical. Okay, so I'm just going to subtract the 1 from both sides. Can I get that? Okay, so now, here's the thing. I isolated the radical, and I developed a new equation, right? I know it's okay to do it because I've got the same thing on both sides, or I did the same thing on both sides. But now, think about how that changes this picture, okay? If I take the red one, and I subtracted 1 from it, right? Hopefully you know from Algebra 1 and Algebra 2 what that does to that line. It did what to it? Okay, with lines, you can think about it as it shifting to the right or shifting down, okay? So that's what happened. If you think about, look at this point right here. If it was just 2x, go back to its original function. That point shifted up 1 unit, okay? And now, subtract the 1. My cursor is that point is going to shift straight down to that point. Okay? Now I'm going to do the same thing here. Okay? Most people will probably just delete the 1, so go -1 here. But it shifted that down 1 unit as well, right? Where is the x value that they still intersect at? Still -1/4, right? So the solution for this, okay, it's a different equation, right? But that solution is still a solution to this thing up here, okay? So every time that we go through and we do some work to an equation, we're getting a new graph. We're getting a new visual. But the solutions to those new lines of work are still solutions to the original, okay? Or these new solutions contain the original solution, okay? And that might be a better way of saying it for what we're going to do next, okay? It just depends on the type of person you are in regards to your positive and negative values. I like to do this. It's not a big deal. But I just like to make my square root or my cube root or whatever. I like to make it positive. So I'm going to divide everything by negative. Okay? And all that does, again, changes the equation. Okay? But all it does, if I multiply this entire thing by -1, it just takes the red line and it reflects it over the x-axis. Okay? If I take this entire thing and multiply it by -1, flips it over the x-axis. Where do they still intersect? Still a -1/4, right? Okay. Now we get to the stage where we've isolated the variable. Okay, or not the variable, the variable term, but we've isolated the radical, right? Now we can get rid of it. How am I going to get rid of it? I'm going to square it. Square that. Square that. Okay. Right hand side is pretty easy, and this is the reason why we wanted to isolate it, is because whenever you square a radical, you're just left with the radicand, right? The left hand side, just be careful here because you got to FOIL that. So it's going to be 4x squared. Okay, then what? Minus 4x plus 1. Okay? Now think about this. That equation, that one there, is drastically different than that. If we look at the picture of that, go back to the original one we had. Okay? If I do that to me. There we go. Alright, so those two things are the original problem we had. Set them equal to each other, we get that intersection point. Now, after squaring, we have developed 4x squared plus or minus 4x plus 1. We get that parabola, right? And now, with the other side of 2 minus x, we get that line right there. Okay? Solutions are where the curves intersect, right? So when I solve this, because we have the ability to solve this, you guys can do this, we're going to do this. But solving that should give us two solutions. Every time I have a quadratic, I should get two solutions, right? Okay? Well, if I'm going through this word, I know my original problem only had one solution, right? I'm now solving this stuff, and I'm going to get those two solutions. Now, if I look at those solutions, and if I look at point B, is it still negative 1/4? Okay, but C is now 1, right? Okay, so we get more than the solutions that we were really interested in. Okay, and that's what we got to think about as we're doing this problem. So we're going to go through the algebra of how we solve that, but then because of this image, we got to do one more step when we're done. Okay, or before we're done. So I'm going to try to isolate this stuff. Okay, I'm going to, just so I don't run out of room on the bottom of the board. Are we okay if I erase the stuff up to this? Rewrite that up top. 4x squared minus 4x plus 1 equals 2 minus x. Okay? So now our goal is, now can I factor this? Okay, I got something squared, you want to factor. We're going to go 4x squared. Add my x to both sides, so negative 3x. Subtract my 2 from both sides, so I get negative 1 is equal to 0, right? So now the idea is that this whole side over here, okay, we're now going to take basically the orange line and make it y equals 0, and we're going to take the blue curve and make it that new parabola, okay? But when we do that, I'm just going to draw them on top here. When I do that, if I have 4x squared minus 3x plus 1 minus 1 and y equals 0, or I gotta have y equals 0 for that. Y equals 0. Okay. If I ask it for the intersection of that purple curve and that x-axis, okay, I'm gonna do it. I don't know why it's saying question marks there, but you can see that where my cursor is right there, does that point look like it is directly below that point of B? So it would tell me that they have the same x value, right? Okay. Is that point right there, that x-intercept, directly below point C? All right. So that's what we're looking at when we solve that equation. And I don't know what I did wrong there with GeoGebra. That just gave me question marks, but you're right about it. All right. So now we think about this, and remember all your factoring techniques. First thing, see if there's a GCF, a greatest common factor. So I'm going to look, see if I can make this a 1 by dividing everything by 4. That doesn't work, right? Okay. So the next thing is to try to do our A times C method. Okay, remember that from last year? Take my first term times my last term, come over the side, write down that number, negative 4. And now I'm trying to think about two numbers that multiply to give me negative 4, but add them to give me my B term. So what are those two numbers? Negative 4 and positive 1. So now I'm going to rewrite this. Okay? And really the only thing that's going to change is that the negative 3x is going to become this sum here. Negative 4 plus 1. And it doesn't matter the order that you do it. So I'm just going to go 4x squared minus 4x plus 1x minus 1 is equal to 0. Okay? Notice here, that those two terms, the negative 3x and then this sum, still say the exact same thing, right? So we're kind of undoing that combining of like terms idea. Does that make sense? Okay? Now people say, well, why didn't you make negative 3x? You could have made that, I could have rewritten that as maybe negative 10x plus 7x. Yes, I could have, but just choosing those arbitrary values does not develop these groups to have common factors in them. Okay? So that's the idea. That's the reason we take the A times C, because we want common factors in this group and common factors in that group. Okay? So what do these two things have in common? 4x. And then that's going to give me what? X minus 1. Now this is what I'm hoping this set of parentheses here looks like, right? And it's already that way, right? So I don't want to alter that. I don't want to change that. but I still need a number out here. So what is the one number that I can divide out so it doesn't change that quantity? Just one. Okay. Now, if you're a person that would have written the 4x squared, do it real small here, 4x squared plus 1x minus 4x minus 1 equals 0, okay? You can still group that way. And now what would come out of these two? Just an x, okay? And that would leave me 4x plus 1, right? What's going to come out of these two? Negative 1, and that would just leave me with a 4x plus 1 again, right? And if you think about these, that's going to be a factor. X minus 1 is going to be a factor here, correct? 4x plus 1 is going to be a factor, right? Am I going to get the x minus 1 as a factor here? Am I still going to get 4x plus 1 as a factor? Okay? So when and people always ask me, I don't know, why did you choose to put that one first, that factor first, when you rewrote that middle term? I just wrote it the way I did it here. And I don't care how it is, because it will always work, regardless of how you order those two middle terms. Okay? So now x is 1, right? Would you guys agree with that? X is 1. And then x is negative 1/4 there. Those are the two solutions. But remember what we did. We squared things. Okay? We went from this being the original graph, and we wanted our x value to be the solution that came from this original set of graphs. We squared things and got something completely new. Okay? When you square something or raise it to the third power, or sixth power, or whatever, you change the dynamics of the graph. Okay? In the original problem, they asked me, what was the solution to this equation here when I had 2x equals 1 minus the square root of 2 minus x? That problem did not know that I was going to go through and square it and get some solutions that are extra solutions. Okay? It's not going to tell me as I go through, hey, remember that when you're done, this one doesn't work. Okay? When you just got to keep in the back of your mind all the time, when you do something, how does that impact the next step? Okay? And when I squared something, that's going to impact in a few steps what I have to do. And I have to check these solutions. Okay? So I'm going to go back to the original equation. I'm going to plug in negative 1/4. Okay? So going back to the original equation. We got 2x equals 1 minus radical 2 minus x. If I plug in negative 1/4, I get negative 1/2 there, right? 2 times negative 1/4, negative 2/4, reduce to negative 1/2. Over here, I'm going to get 1 minus, now 2 minus negative 1/4, okay? 2 minus negative 1/4 becomes plus 1/4, right? Okay? Now, so I want to combine these, and I want to take the square root of a sum. I want it to be easier to take square root of a rational number. So I'm going to change this to, is 2 the same thing as 8/4? So now that gives me negative 1/2 is equal to 1 minus 9/4. And even though that's a fraction, that's a perfect square, isn't it? I say negative 1/2 is equal to 1 minus square root of 9 is 3. Square root of 4 is 2. What's 1 minus 3/2? Negative 1/2. So by plugging in negative 1/4, we see that the left-hand side and the right-hand side are in fact the same, right? So that tells us that we have with negative 1/4, we have satisfied the original equation. Negative 1/4 is a solution. And that's what was mimicked by the graphs. Okay? Now I try 1. If we think about the graphs, this should not be an answer to that original 1, right? Okay? So we already know it's not an answer. Well, let's see what the math looks like when we plug it back in and see how we can then compare the math to what the picture looks like and how we can use that then to help us later to realize, without a picture maybe, what an answer is and what an answer isn't. Okay? Which ones work, which ones don't. So if I plug 1 back in, I get 2 on the left-hand side. I get 1 minus, 2 minus 1 is just 1 there, right? Well, what's square root of 1? Yeah. So left-hand side we say is 2. right-hand side became 0. Are those equal? No, that's a left-hand side does not equal the right-hand side. So that tells me when you substitute back in and you get a false statement, it tells you that that solution that you thought was a solution is actually what we call an extraneous solution. It's an extra one that's developed from the squaring process that you always have to check and decide to eliminate. Okay. Now my thought is, sometimes you're going to want to be cautious just because this one worked doesn't always mean that one won't work. Okay. What if I had? What if my original function would have been like, let's go like 2 9x, see what that looks like. How many times now? How many original solutions would you have here? You intersect once there, right? You intersect once there, right? Okay. So when you alter that, like 2 9x equals 1 minus the square root of 2 minus x, you alter it, create a quadratic equation. That quadratic equation is going to have 2 solutions again, but both those solutions are going to work. Does that make sense? Because of how the first picture kind of intersecting, how those first 2 graphs related to one another. All right. So I want you to make sure that because a lot of people want to do this, they want to shorten their work, but there's nothing wrong with that. But know when you can and when you cannot shorten your work. In this situation, if you don't know what the original graph looks like, you can't just say because that one works, I know that one won't. Okay. If you do have that information about the picture, you can probably shorten your work. You don't have to check the one. But generally speaking, we don't want to have to go through all the work of graphing these things and then doing the algebra. The results tell us the same thing. So, squaring something, cubing something, always go back and check your solution. Is that okay? You might see something in your homework, whether it's this weekend. I'm going to change your homework to be due on Tuesday. So you have time to ask questions on Monday. But you might see something, we're not going to work all the way through this. But if I have like radical 2 plus x plus 3 equals the square root of maybe 2x or something like that. Okay? You have 2 radicals, right? Okay? When you have 2 radicals, what you want to do is stay true with your idea of isolating a radical. It doesn't matter which one. So here, hopefully you recognize that this will probably be the easiest one to isolate, right? It's already by itself. So what you do is you isolate this, and now you try to get rid of that radical. Well, how would I get rid of that radical? I would square both sides, right? So I would get, 2x here is equal to, now if I squared this side, I'll get 9, I'll get 2 plus x, and then when I multiply those 2 together and double them, it should give me 6 radical 2 plus x underneath the radical. Okay? It got uglier looking, right? Got more terms now. And I can combine some of those. But what's nice about that now is how many radicals do you have? 1 now. You went from 2 radicals now down to 1. So now you got a new equation with 1 radical in it. So what do you think you do? You're going to square it, but what do you got to do first? You got to isolate that. You got to get that thing by itself. So you got to move everything else to the other side, and then you can square that. You can square that other side, and then keep working. Okay. So however many radicals you start off with, 1, 2, 3, 4. You keep going through the process. You initially think isolate a radical, and then square. Okay. And you keep going through that process until you eliminate all your radicals. All right. Your work is going to be a lot easier if you remember to isolate. Okay, a lot of times people will not isolate; they'll just start squaring right away, and they start making things look more complicated, and then they give up and they get frustrated. So make sure that you isolate first, square, get rid of the radical. If you still have a radical left over, isolate again, square again. Keep going through that process till they all disappear. Is that okay? All right. And then when you're done, take your answers, plug them all back in the beginning, to see if they work. Alright, so these two slides talk about those extraneous solutions.